In May 2026, the MV Hondius, a Dutch-flagged expedition cruise ship carrying 149 people, was navigating the South Atlantic Ocean. During the voyage, a severe illness swept through a small group of passengers. They developed fevers and gastrointestinal distress, which quickly escalated into acute respiratory failure as fluid filled their lungs. Within weeks, 7 people on board had fallen critically ill, requiring urgent medical intervention. 3 of them died. When international health agencies analyzed the test results from the evacuated passengers, they successfully identified the pathogen. It was a hantavirus, an isolated ship, a highly lethal pathogen spreading, and an immediate public fear that a new respiratory virus was about to sweep the globe. Typically, a hantavirus infection is a dead-end zoonosis. Humans catch it by inhaling dust contaminated with the urine or droppings of infected rodents, and the virus stops there. It does not spread to anyone else. The pathogen on the MV Hondius was a specific strain known as the Andes virus. When it triggers severe respiratory illness in humans, the case fatality rate sits between 38 and 50%. This flowchart illustrates the biological anomaly. What makes the Andes strain unique among all known hantaviruses is that it is the only one documented to transmit directly from person to person. A pathogen combining a massive fatality rate with human-to-human transmission is the exact biological profile that tests our global pandemic readiness. To understand how the virus reached the ship, investigators traced the itinerary backward. Before boarding, passengers had traveled through Argentina. This specific region of South America is the endemic home of the long-tailed pygmy rice rat, which serves as the natural animal reservoir for the Andes virus. This epidemiological report shows the timeline. One passenger boarded the ship on April 1st after traveling through that endemic area, already carrying the virus, and fell ill on April 6th. Looking at the specific case histories, the illness then spread selectively to that passenger's partner and a handful of individuals who had shared close quarters, eventually triggering intensive care medical evacuations in South Africa. By tracking exactly who got sick, epidemiologists noted a critical detail. Out of 149 people in a highly enclosed environment, the virus only managed to infect 7. If a virus can spread between humans and is highly fatal, we have to ask why it didn't tear through the entire ship. Highly contagious respiratory pathogens, like measles or COVID-19, are optimized for airborne spread. They can linger in the air and travel across rooms, easily infecting casual contacts. This diagram compares transmission radii. The Andes virus lacks that airborne efficiency, requiring close, prolonged contact. In epidemiological terms, this means spending significant time trapped in tight, enclosed spaces, or having direct exposure to an infected person's bodily fluids. An infection can be exceptionally lethal to a single patient, while remaining biologically inept at sustaining widespread transmission across a population. Because the virus is so poor at spreading casually, health authorities were able to neutralize the outbreak using standard containment protocols. According to the official infection prevention guidance, symptomatic passengers on the ship were immediately isolated in single rooms, and the crew implemented strict droplet precautions. Health agencies coordinated carefully controlled medical evacuations, moving the sickest patients directly to specialized intensive care units without exposing the general public at port cities. For the passengers who disembarked, health departments enforced a rigid 42-day monitoring period. The 6-week window was intentionally designed to outlast the absolute maximum incubation timeline of the disease. Without the ability to float casually through the air, the pathogen's transmission chain is completely severed the moment infected individuals are isolated. Following the containment of the cruise ship passengers, major agencies, including the CDC and the European Center for Disease Prevention and Control, concluded that the risk to the general public was extremely low. Even if a case slipped through, the virus faces a massive geographical barrier. The specific rodent species required to naturally harbor the Andes virus does not exist in Europe or most of the world. A high fatality rate naturally generates terrifying headlines, but severity does not automatically equal pandemic potential. For most people, the real threat isn't an exotic person-to-person strain, it's the standard hantaviruses carried by local wild mice and rats living in their own regions. The most common way people get infected is by making a simple cleaning mistake. Dry sweeping or vacuuming up old mouse droppings aerosolizes the deadly viral particles directly into the air you breathe. Prevention relies on sealing building gaps, storing all food securely, using wet cleaning methods, and disinfectants to neutralize the virus. When we understand the specific biological mechanics of how a disease actually spreads, we can replace panic with targeted, practical preparedness.